how did I end up in Alabama, of all places? And my journey started in Charlottesville back in 1998, and I came in first-year engineer, not even sure what I wanted to do aside from engineering. I was trying to decide between civil engineering and mechanical engineering, and eventually met more of the civil faculty, decided I liked them, wanted to be in their classes, and that kind of got me on the way. As we go through this, I'm going to take you from Charlottesville down to my time at Norfolk Naval Shipyard, all the way out to Austin, Texas, where I did my graduate work, and then finally landing up in Tuscaloosa. And as I go through this, I'll try and talk about how what I've done relates to transportation. And we'll start with my inspiration for becoming an engineer in the first place. This is my grandfather, Harry Ramonti. He was a navigator on B-24s in World War II. Flew missions out of Italy, over Romania, and Germany, and other places in Eastern Europe. After the war, he spent a little bit of time in Guam, killing time in the reserves, and then went on and came back to Auburn, New York, and got his degree in architecture, taking night classes with the GI Bill. So this is him in 1962, working at his firm in Auburn, New York. He eventually rose to become a partner in that firm before retiring in the mid-'80s. And along the way, he actually designed his own house. That's my dad standing in front of the house that my grandfather designed. And I think that's just cool. Designing your own house. He had a little bit of Frank Lloyd Wright in him, the flat roof, and it's just very, very 1950s. And just driving around town with him, having him point out, oh, I designed that, I designed that. He bought me books that kind of nudged me in that direction. So that's actually a picture of probably one of the more influential books for me growing up. Just loved reading that thing, learning about buildings and roads, and that's all the great things that civil engineers could do. And also my grandfather on my father's side of the family was from Long Island, New York, so we go down and visit them quite a bit. Got to see all the great bridges in New York over and over again on all those trips. So that's the Whitestone Bridge, probably one of the more common routes into Queens that we would take. And again, looking at all these bridges, that was really, to me, the epitome of civil engineering. This is the building bridges, helping connect cities and bring people together. I eventually ended up at UVA. Left Syracuse, New York one morning, drove down to Charlottesville, left, and it was snowing in the morning in Syracuse. I got down here, 70 degrees, sunny, magnolias were in bloom. So I immediately fell in love with the place, decided to come here. Along the way, I worked for Whiting Turner Construction. It's me on the right. I'm not actually on the phone, so you can picture me with a cell phone. And then we were actually building the expansion to the Darden School at the time. So on that project, we got to see precast concrete construction with the parking garage, steel frame construction, cinder block construction, everything going from holes in the ground to finished buildings, and that was really awesome. Up on the right, I had to take on your department chair for a second in C Systems class. Brian could not stop tripping over the extension cords. This was back when he had to wheel in a cart to bring a projector into the room. He was one of the first guys using PowerPoint in the classroom. So he had about 18 cords connecting his computer to the projector, and extension cords running off that every single day. He tripped over it. Really involved in concrete canoe, so this is really my first hands-on exposure to concrete. That's eventually where my career would take me. I don't do transportation engineering as you might think of it normally, but I do research on materials that are used in transportation structures. So a lot of my research is tied into transportation agencies. That canoe did not do so well.
I have some of those.
That's the only picture I've got of concrete canoe scanned in. And unfortunately, we were kind of heavy in the back, and the Virginia Tech team kept yelling at our team, go, no, you guys need to get further back in the boat. People on shore are yelling at us, you got to go forward. I was listening to the Hokie, and as soon as they started paddling, water started pouring in from the back on that race. And you can actually find this photograph just down the hall. That's the class of 2002, and I'm right here in the back, top left row. So in May of 2002, I got my degree. It was time to get a job. I got to say, been at 3 different institutions now. Nobody does final exercises like UVA. Keep the balloon. Keep that vested. That's great. I really enjoyed that day. The next place my career took me was Norfolk Naval Shipyard. I spent 5 years there as a naval architect. And for those of you who don't know what a naval architect is, basically a civil engineer for boats. I worked on naval ship overhaul and repair, worked on carriers, amphibious assault ships, several classes of submarines, and nothing I'm showing you up here is classified. It's actually a photograph off Wikipedia. And as I got into this career, it was ultimately not where I wanted to spend the rest of my life, but I did learn some useful things there. Much of our engineering was really just kind of Xerox engineering, copy and paste the same document and change the name of the ship. So a lot of days it was kind of dull for me, and people say, oh, you worked on submarines, that must be really cool. Well, yeah, and I wrote instructions for people to go work on submarines most of the time. But the USS San Francisco actually ran aground en route between Hawaii and Australia, and that's the kind of damage that happens when you run into an undersea mountain that's not on the charts. So they almost lost the ship, but got it back to Guam under its own power, and this was probably the single most interesting project I worked on while working for the shipyard. So about a month and a half after this happened, the team from Pearl Harbor Shipyard that had gone out there was ready to rotate back. They had already spent 6 or 8 weeks on Guam working on this. My boss says, hey, can you go to Guam? I guess I could. For how long? He goes, oh, about 5 weeks. All right, yeah, I guess I'll go. I haven't got anything else going on in my life. So I went over there and we worked on coming up with temporary repairs to get this ship seaworthy again. And what's really interesting about this is the ship lost about, I would say, somewhere in the neighborhood of about 500,000 pounds to 1 million pounds of mass in the front. There's equipment in there you really can't talk about, but it got destroyed. So they just torched all that off and cut it away. And what you really just wanted to have was something that was seaworthy going back. So we had to find a ballast system for the ship so that it would be seaworthy to get back to Hawaii under its own power. And what was cool about the project is it wasn't Xerox engineering at all. It really got to be an engineer. And that's where I learned that what I really wanted to do is probably what engineers should be doing, which is solve interesting problems. And so I wanted to find a career that was going to let me get out there and attack different and challenging problems all the time. And photo up on the right, by the way, that's the only existing photograph of me working on the waterfront at Norfolk Naval Shipyard. You really can't take photographs down there on a regular basis, but one day we managed to get 3 of us from the office together and got our photograph in front of one of the submarines. So that was kind of nice to be able to share. And when I was working for there, I also was a travel bug. Saved up some time, spent a month traveling in Europe, and I was really struck by the different approach to transportation there, the intermodality of everything. And this is about an hour after I arrived in Amsterdam. I took a train from the airport to Amsterdam Central Station. Went up there, I could walk where I was going, I could get on the tram, I could get on a bus, I could get around, I could rent a bike if I wanted to. A million ways to get around. It was so different from trying to get around Norfolk and Virginia Beach, where you're really kind of limited to getting in a car, and that was about it. So that was very interesting to me. Other areas, intermodality doesn't really exist too well. It's ferrying in Poland, it seems to be missing its ferry. And this is from one of the several trips I've taken to Chicago to, got several cousins that live there, visited that. Kind of love this for the artistic element, but also I was definitely fascinated at the time with different ways of getting around. And as I'm contemplating going back to school or back into civil engineering one way, how do I get back to solving problems? How do I get to something that's going to challenge me every day? And at consultations with faculty here, in fact, Tom Baber really took a lot of his time, or gave a lot of his time to help me figure out what I wanted to do next. I applied to several graduate schools and settled on Texas. Drove out there. This is my trusty Saab that I bought when I graduated from UVA, and I had until I got to Alabama. I decided I was going to study concrete. I was going to study civil engineering materials because they're always changing. You can make concrete into just thousands of different recipes. You cook up whatever you want, whatever you need for different applications. And that to me is amazing. As a master's student, I worked on federal highways funded projects to try and find ways to treat transportation structures that were affected by alkali silica reaction. I'm assuming most of you guys are transportation folks, so if you don't know what alkali silica reaction is, this is a massive reaction that can happen in concrete when certain aggregates react with alkyls and cement paste. And federal highways at the time was in the midst of multi-million-dollar research effort to try and find ways to stop this reaction in its tracks in existing structures that had it. So we had several field sites. This would be me working on a pavement in Mountain Home, Idaho. Here we are getting a truck unstuck from the mud in Houston, Texas, working on the grassy side of an overpass structure. And over there, this is me in Massachusetts working on a concrete barrier wall. And we sprayed a lot of lithium on stuff, and then we try and see if it actually did anything. And eventually we learned a couple problems were present. One, lithium didn't really want to go into the structure, and so therefore it didn't really do anything. Federal Highway spent a lot of money trying to figure this out because there were a lot of companies pushing them very hard to say, no, it does work, it's going to make your concrete better, it's going to save these structures. And so what we did was really instrumental in finding out that it didn't do much. But on the upside, we went out to the last trip, and we at least got to go do some trout fishing and managed to work that in on a bad weather day, I guess. And before they were wrapping all that up, we got to do one last effort here. We're going to do a laboratory control project. So we're going to build all these simulated field structures in the laboratory or outside our laboratory in Austin and do a much more controlled study. We know exactly what materials went in. We know exactly how damaged they are when we treat them, and pretty much control everything but the weather. We made 160 large-scale specimens, I mean something that's at least 3 feet by 3 feet in size. And this is what we're doing in the last week before classes started that summer. We got just a ridiculous amount of concrete. It's a real team effort, and it was a great opportunity to work with my fellow graduate students and also some of the undergrads working in the lab. And the real benefit of doing this kind of work is that you're getting your hands in the concrete, you're getting to feel what it is. You learn so much more about the material and the structures that are going to be built with it if you get to actually make the materials yourself. Here I am shoving some concrete out of the ready-mix truck, and this is just a nice bird's eye view. And again, this is what we're doing the day before classes started in the summer of 2009. Or sorry, summer of 2008. 2009, I took off to Quebec. Took a short trip that my graduate advisor decided to help fund. We're going to make some connections with Benoit Fournier at Laval University and Patrice Rivard at Sherbrooke University. And Benoit has really been one of the preeminent experts in alkali silica reaction from a geological perspective. He spent about 20 years at the Canadian National Labs in Ottawa, and then moved on to Laval University after that. And one of his, I guess, keynote projects was working on this bridge structure here, where you have these V-shaped columns. They were really badly damaged by alkali silica reaction, and they got to try a whole bunch of different min measures. And just like highways field trials, really not able to slow things down, although you can kind of patch over and cover things up. Ultimately, this was torn down not because the structure itself was at risk of falling down, but because the intersection or the interchange that this was a part of was accident prone. So they decided to redesign the whole interchange, tore out the bridge, and Benoit got to salvage some pretty large chunks to take back to his lab and study them in greater detail. PhD students, we were also responsible for leading the lab in our weekly shrimp boils and crawfish boils. So didn't have plenty of time to have fun in grad school. Had time to give back. This is, as a civil engineer for a long time, I felt that I should be involved in Habitat for Humanity. At the urging of Jack Green, who was National Academy of Engineering member and professor at UT Austin, he invited our class out one spring to go help out on a field, and I stayed with that ever since. The rest of the time I was in Austin, we built 7 houses, and we had a great bonding opportunity to get to know and fellow grad students and really give back, learn how buildings are constructed and how they all go together. My PhD project was again a concrete-related thing, but it was also related to transportation in that the Texas Department of Transportation now said, all right, well, if we can't stop ASR, we want to at least find ways to non-destructively evaluate our structures and find out how badly damaged they are. So one of the goals of this project was to come up with or evaluate different non-destructive testing methods for structures that are affected by alkali silica reaction and another form of distress called delayed entropy formation. And they were also concerned with what the flexural capacity of some of their bridge bend caps that were affected by these forms of distress. So we did a mix of casting from large-scale specimens, small-scale laboratories, and really just threw the kitchen sink as far as commercially available non-destructive testing techniques at the problem. We also had a little bit of fun making tons of concrete. That's actually helped me become an expert in how to make big things out of concrete. And that's not something that we get at the university level very often. Spent a lot of time out in the 100-degree heat taking measurements on these various specimens we made. In the end, we also got to break them in the laboratory. So the exposure from looking at things at a small scale, millimeter scale for materials, all the way up to something that was 30-foot bridge girder, valuable to get that kind of perspective. Eventually, they let me graduate, and I went off into the real world. And just like some of the other graduates, we're trying to go off and do some great things. This is my friend Catherine Hovell. She graduated from here in 2004 and then went on to the University of Texas, just like me. She now works for QI Lin, and this is her first bridge. This is the new, I think it's called the Tillicum Crossing in Portland, Oregon. How many of you guys have heard about this bridge? It's the first new crossing of the Willamette River in Portland in a number of years, but it's also a car-free bridge. So it's got lanes for bikes, it's got lanes for pedestrians, it has lanes for light rail, no car lanes. And I believe it has some bus lanes as well. But this is really a new thing for that city in that it is a completely car-free bridge, but it's also not a rail-only bridge. fully multimodal bridge, and if you ever get the opportunity to go stand next to a bridge with somebody who helped design it, I definitely recommend taking advantage of it. Had to go to Alabama. It's really not that bad, although prior to going to Alabama, my preconceptions of the state were pretty much formed by Forrest Gump and by Cousin Vinny. So I definitely had my impressions changed when I got there. It turns out northern Alabama is actually quite hilly, and Tuscaloosa really has a lot going for it these days. The university is growing trees, and when I came there and interviewed, it really blew my mind as to what I perceived the University of Alabama as, which was a lot like people made the MBA 20 years ago, which is, it's a place where you go for law and business and not engineering. You do that at Virginia Tech, right? In Alabama, the same view applies to Alabama and Auburn. But our school has grown tremendously, and it's created a lot of new possibilities to do some influential research. So I'm going to talk about a couple of the things that I'm involved in now or have recently wrapped up. Again, transportation-related research. With the Alabama Department of Transportation, first project I had with them was to look at evaluating bridge deck sealers. And these are coatings that you'll place on a bridge deck to help keep salt and water and anything that gets dissolved in water that might attack the steel or the concrete out. Our job was to take samplers and apply them to concrete and find out which ones did the best job keeping water and chlorides out. And figure is up there on this is a micro X-ray fluorescence scan specimens that were treated with several of these sealers, and we came across unsurprising results. A couple of the sealers did a really good job keeping everything out. All the purple that you see is fluoride penetrating into the concrete. And on the right, we have a sealer that actually somehow invited more fluoride into the concrete than if there was nothing there at all, which was really shocking to us. The other project that I'm involved in with Alabama DOT is titled Friction and Texture Retention of Concrete Pavements After Diamond Grinding. It's a real mouthful. We've got co-funding from the Portland Cement Association, and this is to help figure out which textures you can apply safely to a concrete pavement depending on which aggregates are used in the pavement. If you have good hard granite aggregates, these are very good for skid resistance, but if you have softer limestone aggregates, they tend to have problems with polishing. And so our goal is to help figure out which textures will be the most long-lasting and provide the safest pavement. And two last projects. Well, the top one is not really a project in itself, but along with Federal Highways, I've now had two students working under me that have been received Eisenhower fellowships. Nathan Klenke on the left is a current master's student of mine, and Owen Colleen on the right spent a summer working at Federal Highways undergraduate grants for research fellowship. And below, this is an unfunded collaboration with the U.S. Army Corps of Engineers. Again, if you think about transportation, it's so much more than just a road. This is an old lock structure on the Black Warrior River in Tuscaloosa. It was one of the first structures in the eastern United States that was described to be suffering from alkali silica reaction. It was heavily studied back in the 1950s, and what we're doing now is going back about 60 years later, trying to find out why the reaction works and stops. Because if we can learn that, we can figure out when structures may stop suffering from ASR in the future. So hopefully we'll help the Army Corps figure out how their structures better. With that, I think I'm eating into Stephen's time, so I'm going to, for your time, and I think we'll take questions probably at the end of all of this. So I'm going to go to Stephen.
All right. Well, good morning, rather.
Stephen Jones, one thing that's interesting is Dr. Giannini just said about transportation being more than just roads, and he talked about a water structure. Interesting thing, the state of Alabama has 10% of the U.S., the navigable waterways in the U.S., of the water transportation system, 10% of it's in Alabama, so it's an interesting thing. All right, so this is a funny title here. I'm originally from Alabama, and I did undergraduate at Auburn University, came up, worked a number of places, worked in Washington, D.C. for a while, eventually migrated down to do graduate school. So I'm a PhD from here, transportation in 2001. Anybody ever met Mike? He's retired now. He was my advisor, so that's been a while. So just an interesting thing here. So these are some of the places where I've worked, been involved, and you'll see here, Emily, see this is old school. Before Victor, I actually was full of research council back when it was that. I put here in the center because it's interesting, because we were told to talk about all. So everybody knows TRB, right? So throughout undergraduate, and as I was heading into graduate school, I was actually in environmental. I was all into groundwater and groundwater contamination and working for a professor. And I had to take a class for a design elective, and I took a class that was a transportation class. And it was in the winter term, and the professor said, hey, I'm taking all my students up to this meeting in Washington. You want to go? And I said yes, sole reason that my, at the time, girlfriend, now wife, was doing an internship in Washington, D.C. So I went just for the free trip to D.C. And I went to TRB, and I was blown away by transportation. And here I am. So it's an interesting story there. So what I'll do, rather than run through the whole thing, I thought I would just take a couple of these more interesting things and kind of focus on sort of the tail end of things. Because I've had sort of a mixed bag of, since I finished my master's, including PhD, 20-something years or whatever, about half of my time has been in academics and about half has been in private industry, working for small regional firms. This is a big international UK-based firm that I worked for in Dublin, Ireland. And while I was working in Ireland for a while, I was adjunct professor at the University College Dublin in Ireland. So what I thought I would do is a little of the experience there. So, I mean, I cut my teeth as a traffic engineer. Signal timing plans, optimization plans, all these things. And then I move over to Ireland, and the first thing I had to do was work out the right turn, other side of the road thing. And that was just one aspect, because, over here, we call these phases. Raise your hand if you're like a transportation traffic operations person. Okay, so we call them phases. Over there, they call them stages. What we call clearance intervals, they call intergreens. And so there was sort of this funny thing of just getting the lingo down. But it's more than just the lingo. We base everything here on the level of service, right? A through F. Over there, everything is talked about in terms of percent reserved capacity, meaning when I look at an intersection and I come through and I look at the degrees of saturation of all the movements, and I want to know, well, how many more cars can I get through there? Percent reserved capacity. So it's not just a difference in terminology, it's a difference in how we view the facility. That leads into how it's actually analyzed. So this is, Core Sim. You've seen the suite of the models. You guys probably had courses with Dr. Park and VisSim and everything else. Well, over here, it's a completely different set. Roundabouts, Arcady, Oscady for unsignalized intersections, and then Linsig. So it's a completely different set of sort of underlying analytical procedures, because everything runs back to this percent reserved capacity. And interestingly, all right, here's a little test. Saturation flow rate for a signalized intersection. What's a good ballpark? 1,800 vehicles per hour. But because of the way they do things over there and their lane usages and some of the way the signals, they actually often will do 2,000, 2,100 vehicles per hour. So it's a very different approach to some of these things. Trip generation. You guys have probably ground through the ITE, the trip generation. Over there, it's done very differently. For one thing, they have, instead of those big giant books, they have a very nice software base for it. And the way it works is, and I'll run quickly, is when you start looking at doing a transportation planning exercise, it may be hard to read here, but some of these are like, you know, am I looking at a neighborhood center, a town center? Is it the edge of town? Is it a suburb? A suburb? And the trip generation rates are inherently multimodal. This is Europe, right? So they're looking at, they want person trips, and then you can go back and look and see, okay, well, what is my mode split? So you can actually go in and see what studies looked at buses, what studies involved light rail or pedestrian. So you can really drill down on your mode split. Transportation mode split is different in a town of 50,000 than it is in a town of more than 500,000. So really drilling down so you know the transportation, the traffic, the trip generation data, you really know where it's coming from. So you know that if I'm using these trip rates, they apply to the project that I'm working on. And there's a lot more precision with the systems they use than what we typically use. So that's just trip rates. You've seen that sort of thing. But then what's interesting is when you put out the results, whether you're a consultant doing a traffic study for some private development, an impact study, or you're doing research, it's actually going to tell you, well, you based your trip rates on the town of so-and-so. So then reviewers can go back and say, well, I'm looking at East London, and you used something in the countryside. This doesn't make sense. So there's a lot more accountability. It's very interesting how it's done there. So that's that. But the interesting thing, so when I was in Ireland, I went there not to be just a transportation engineer. This was just a few years ago, so this was later in my career. And I went over there as sort of a career development. So this is my front and back of my business card. My last title there was, I was an associate vice president, and I ran their international business unit. So you can see the countries where the firm had offices, and I was based in Ireland, and I focused on Eastern Europe. And particularly, Iran was on the board of the Ukraine office. So I worked a lot in Eastern Europe, and there was a lot of interesting things that happened with that, because this was pre-global financial meltdown, okay? So this was 2007 to 2010. So the economy was booming, and the projects and the land development happening in Eastern Europe was enormous. Geography, people. The country there in red. Anybody got a guess?
Belarus.
Belarus, he says. All right, so there's Belarus. So if you've not been, sort of a typical Soviet-looking city, this is Minsk, the capital of Belarus. That's me in a subway station in Minsk, and this is my engineer, Andrei Chernovsky. I'll tell you a story about him. He was both a very good engineer and very much a local fixer. He was a Belarusian guy who knew how to make things happen in Belarus. So I convinced my company. We didn't have an office, you'll recall. We didn't have an office in Belarus, but I convinced them to let me chase a big project in Belarus. Now, this is the business climate. Anybody ever heard of KPMG? They're a giant accounting firm, worldwide accounting firm. So we wrote a proposal, and we got a contract to KPMG to look at a land development project in downtown Minsk that was being funded by the government of Oman, the Middle Eastern or Gulf state government. So these are square meters. So it's 3 sites. You can see the square meters. I'm imagining all of you are comfortable in meters, so I won't convert it to square feet. So this was massive development. The price, the original estimate on this was about €1 billion. About €1 billion of development. They were putting in hotels and office buildings and different shopping centers and different things. And so what we were brought in, we wrote the proposal, we were successful, we got the project to do the engineering feasibility of the Omanis. The government of Oman is getting ready to invest €1 billion to build this stuff in Belarus. First thing is the market analysis. Will the market bear all of these things they want to build? The second part of that is, will the local infrastructure accommodate it? Obviously, a big part of that was transportation. Now, but this is the climate. So this is one of the architectural sketches for some of the projects going on. Now, this is sort of funny because you see this shape right here. This is a hotel that was being proposed by an Iranian, an investment group out of Iran. And so this was to be the main road coming in from the airport. So you would sort of come over a hill, and the idea was that as you came in, your eye would see this, and it would look like a diamond ring, with this being the part that held the diamond, and this being the diamond. I mean, these were the crazy kind of things that they wanted to do. And it seems crazy, right? Well,
that's actually there. That's the National Library of Belarus. So the other one didn't get built yet because of the economy, because everything fell apart. But so they were dreaming these things and they were building these things, and it was a crazy, exciting time to be there with things going on. So the first thing we had to do was jump in and figure out, okay, no one in my firm, none of us had ever worked in Belarus. I quickly hired Andre, the Belarusian engineer, and we got in to figure out what was going on. They had, like any good city, they had long-range plans, master plans, and that type of thing. So we got every bit of information we could. So this was they have very good bus and tram systems, as well as an underground metro. So like a lot of former Soviet cities, very, very good public transportation system, but it's never been tested with this amount of concentrated private funded development before. The roadway network. So we were able to get some general information, and we spent a lot of time on the ground. I probably spent 5 months in Belarus, all total over a few years, on the ground, inventorying and figuring out what's going on. But at the end of the day, because we were not doing just transportation. So I led the project from a managerial standpoint, and then I oversaw a transportation team for technical work, but at the end of the day, I'm responsible for everything that's happening. And there's power and utility and all the things. So at the end of the day, we're engineers, and it's not just about big master plans and photographs. We had to do some engineering. And we were getting to the point where we were running up against deadlines, and we had to produce, and we were working in Belarus, and we were not getting any cooperation with the local governments to give us the utility plans. Again, this is former Soviet Union, and this is a country that is closest to the former Soviet Union. Very hard to get in and deal with ministry officials. And so this is the way business works, right? So you remember my guy, Andre. So we had a big meeting on a Thursday. And I sent Andre to Minsk. He was with me in Ireland. I sent him to Minsk a few days early, so he flies in on Monday, and I said, "You've got to get me engineering plans. Just get them." He landed on Monday. On Tuesday, he calls me and says, "Steve, I have the plans, but I need you to wire me 2,000 euros today." I never asked any questions. We got the plans. We were able to go in and do our designs, because we had to go in and lay out what was going to happen, for these new developments. For instance, we had to be able to say, look, this is your current sewer system, your current sewer lines, and we're about to put a hotel here. You got to move sewer systems. Obviously, we needed to know that information, and I don't know how Andre got the plans, but it's the best 2,000 euros I've ever spent. So at the end of it, what happens is we come around and we produce this report. And this is not your typical engineering to a DOT or that sort of thing. We're giving this to a group of investors. They want to know, did you do good technical work? And at the end of the day, how much is it going to cost, right? That's what this comes down to. So we ground through, and this is, I apologize, a little hard to read, but we did, projections of power demand, sewer, water demand, internet, telephone demand, for all sort of the infrastructural capacity issues. And we did what you transportation folks would know of. We did trip generation. Now, the trip generation system that I showed you before, the British-Irish system, it's great, but it doesn't cover the Soviet Union or Belarus. And I promise you that the ITE trip generation that we have here in America doesn't cover it all. So a lot of this was field-based studies and going through a lot of old engineering, Russian and Belarusian engineering documents to see what they've used in the past. So these numbers were our honest, best engineering judgment guess based on all the evidence we amassed. And that's how engineering gets done sometimes. There is no exact solution, and that's what we had to do. So we came up with it, so we were able to say, these are the trip rates we're going to use, and we can come up and say, all right, for these particular intersections, given the traffic out there, and you project what the traffic is going to be, percent reserve capacity. So this particular area here, this intersection, in the AM peak, we had 99.3% reserve capacity. So in our world, that's a really sweet level of service A, right? They've got a lot of capacity out there, which meant you're not going to have to do anything to this intersection. at least accommodate AMP. Little tighter in the PMP. But so that was sort of the traditional, we're doing traffic engineering, that type of stuff like we do. We had to go in and actually do studies to get an idea of headways and vehicle capacities on the various public transportation routes, so that we could do projections to say, look, this is what you've got out there now. This is the capacity of the current systems. When we put in a 20,000 square meter hotel and a conference center and these other things, this is going to be the peak hour demand generated. Can you accommodate it? So this was the kind of thing we were doing to say, because if you can't, if you're going to have to add vehicles, well, that's an investment. That's going to cost some money. Or if it's in the case of a tram, of a light rail or a heavy rail, adding vehicles is not just like adding a bus. I mean, it's adding vehicles, it's adding complexity into the system. You might have to upgrade control systems and different things. So we had to go through pretty detailed, again, sort of best engineering guess on this to move them forward. And at the end of the day, what they wanted to know was, how much is it going to cost? So I just picked one of the sites at random. So here's the capital, all the different things. What's interesting here then is when you come down to the end to upgrade this one site, this is not building the hotel, building the shopping center. It's just getting the site ready to build the things. Before any of the, one of the things they were going for, they were shooting for LEED certification. They wanted Google's Eastern European headquarters there. They were going for very high-end building. But before they did any of that, at least for this one, I think this was site one, it was going to cost, the estimate was a little over 20 million euros just to get the site ready from an infrastructure standpoint, and about 8 million euros of that was transportation related, upgrading the roads and some other things. So that's sort of my trajectory. I'm a transportation professor now, but going back and forth into industry and then back into academics and then back to industry again. This is really sort of the business end of it. Now, from a research perspective and kind of where I am now. So I'm at the University of Alabama. My bread and butter work is just like the Victor. There we go. I still want to say the research account. Just like Victor and its relationship with UVA here. A lot of what we do is serving the Alabama Department of Transportation, and some of it, like what gets done at Victor, is not even exactly what you'd call research. It's more service research. It's helping ALDOT do things better. It's setting up standards. So in the last few years, I've authored these documents for the state of Alabama. Alabama is not the most, from a transportation standpoint, not the most progressive state in the U.S., and we are just now getting on board and really rolling out roundabouts. And in fact, next week I will be doing the first set of training on roundabout design and analysis in Alabama. And so we hope to see that changing and roundabouts coming forward. So a lot of that sort of thing. And then beyond that, we're doing a big project right now to evaluate some SCATs, some adaptive traffic signal system deployments in Alabama. That's a lot. I mean, we're doing VISM again, Bryant Park. We're doing VISM. We're doing the thing where we're actually running the SCATs, the control logic within the VISM, within the simulation environment, and doing that sort of thing. A lot of the safety stuff. Pretty heavily involved in running. What time I forgot? All right, we're good. Because I want to leave questions. But so pretty heavily involved in implementing the new highway safety manual and some of the new safety analyses, standards, and practices in the state of Alabama. So a lot of that. And then this is, again, sorry, the screen's a little smaller. One of the things that we took on recently, again, this is that service kind of research to the Alabama Department of Transportation is the federal government has there, maybe some of you have heard of it, FHWA has the HPMS, the Highway Performance Monitoring System. So this is what they do. They count traffic and based on the number of miles of roadway, VMT on different types, different functional classifications of roadway. Every state Department of Transportation submits that to the federal government. They run it through some formula, and that's how they allocate funding to the DOTs. So obviously a pretty important thing for the state of Alabama because this is how they get their funding. And so we at the University of Alabama, we actually run that program for them now. I mean, we have a firm that actually physically does the traffic counts but we schedule and do all the quality, QA, QC on the data, and we run that program for them now. So that's cool. I mean, it's a good project. It's good that we do that for the Alabama Department of Transportation. They needed our help. We stepped up and we do that. So the other side of it, from a research standpoint, is we got all the data. I mean, all of the ADT, all the traffic data that's used for safety modeling and all the other aspects, we control it. And so that's been a great sort of central repository for that information. Now, beyond that, and I guess some of you will be because perhaps your professors make you, but I certainly would hope that you would come. So the other thing is, in the last several years, certainly since I've been back from Ireland, been able to pursue something that's long since been a personal interest and a personal passion, is I really focus on transportation in developing countries right now as much as I can, specifically sub-Saharan Africa. And I'll talk really in much more detail about that later today. But so that's me from, a graduate student in Alabama. I came to UVA. This is interesting. I was actually a student at UVA at the same time Brian Smith was. We were in the program together. All right. And then, because these things happen, my wife, who was here doing her PhD in French literature, we found out we were having twins. So we jumped ship. We didn't want to do that on a graduate student income, so we left and went back, and I got a real job and worked in consulting for a while. Got our feet on the ground. We came back to Virginia, and I finished my PhD, and I've now gone back to Alabama. So that's the reason for the title. And so now I'm back in Virginia again today, and obviously happy to be here. So that's sort of the pathways for Eric and I. Any questions, comments on things technical or not would certainly be welcome.
I have a question.
Yes.
So, like you went to Ireland for the work, so and also worked on many international projects. How did you manage to, get yourself adjust or comfortable reaching their local roots or those kind of?
I'll be perfectly honest. Sometimes it was easier than others. I mean, sometimes the lessons were hard learned, and I'll give you that. Because again, transportation people. I was involved in and this was actually in Ireland. It was a very large private development, and there was a mid-level, a younger engineer, very good engineer that was working on the project, and then he left and took a job somewhere else. And something was changed on the project, and we needed to do some final analyses. I understand traffic flow theory. I understand simulation modeling. And so I went from never using this one, it was Paramix, that simulation family. Anyway, long story short, I went in, as you would do. I took what he did, file, save as, and I made some changes just in some small lane configurations, and we did it. We finalized the results on that, and along the way, found out that there were no yellow times. There were no clearance intervals. Now, I've been around doing traffic engineering. I know that you're supposed to have clearance intervals. And when I went into the software, the part at the end where I'm making the changes that I'm making,